All right, practical notes before we start. First things first. The device turned out to be supported, as far as I could tell, in its entirety. There are bits that I haven't yet tested, namely the NVMEs. As far as I can see from the boot process, they are recognized, and they're not active because there's nothing plugged in there. So that is a good sign. The other thing that I want to highlight is the fact that the hanging that we saw was a byproduct of basically the eMMC having some remnants inside that was interfering. I can't really get a full understanding of why that is and how. But after going through the procedures that you're about to see, you will be able to recover and make the installation go through all the way to the steps that you can actually go forward with the installation. More things. The recovery and the bricking. I bricked the device because I was trying to do a USB pass-through to use the Windows version of the tooling, because the vendor said that the Mac versions of the tool, the upgrade tools, didn't quite work properly. I ended up taking a chance, and I was able to use them. My advice would be to use the Linux ones. I would say they're easier to go through in this case, but we're going to see that in a minute. And that's pretty much it. Once you understand the layout, it's very important to pay attention to the layout of the eMMC, because we are going to put a boot to replace the bootloader, and it is to be expected to be on a specific offset. And if that's not the case, you're left with a device that is in an unbootable state. Okay. So let's do something. Okay. So you're going to see a few things, and I'm going to call out before we start. The most practical way to interact with this is actually to use the upgrade tool. You're going to use a number of commands, the DI, and then there's short names for those, the carry for kernel, a resource RE. These names change from device to device, even from Linux builds that you try to load. You will eventually do an RD, which is basically a reboot of the device. It is different resetting the device from here or resetting the device from the buttons that it has, especially after you load the bootstrapping binary that you use to recover the device. That is another catch. Okay. My current understanding of it, at least in the device that I have, is it is that I can consistently recover the device using this loader here instead of the one that comes with a given Linux build image. You will have, each image build will have a mini loader in it. And so I'm left wondering what kind of differences there are, but I haven't yet gone through this over here, which is some of the scripts and the toolings and whatnot that that is used to build those things. There's also this repository here, and you can clearly see the loader there, the SPL loader here. So the boot process is fairly simple. You have this bootstrapping that is used to put the device into a state that you can flash it, and after that you have the bootloader itself and everything else. So there are minimum requirements for you to some of those things you actually need to load before you start the OpenBSD installation, namely the mini loader and the U-boot that comes. I've used one from the image that I used to recover the device from the brick state that it was, but eventually it's going to be replaced as soon as you finish the installation. Do not override the bootloader U-boot before rebooting the device once you finish the OpenBSD installation. Once the OpenBSD installation is finished, you need to reboot it with the SD card in. Interrupt the load. Make sure it loads from the eMMC. You're going to see the command in the video as well. Once that happens, find out the eMMC's device ID, and then flash the U-boot. I tried to do this as soon as I finished the installation, but I didn't get a good result. It was basically unable to find the EFI partition. So there might be something in there. Okay, and that's going to be pretty much it. If you are trying to recover this from the Windows version, call out to one very crucial detail. Okay, they point out that you should load this, and there's a configuration file that you can use to load this thing and point it to the right location. Okay, going to see the device in mask mode. Go to the advanced, which is going to be this screen over here. Going to select the mini loader, do download, and after that, if you press chip info, you should see something in there, and it is going to be awesome. You're in good state. Okay, then you may try to clear up the flash like this, and after this, if you want, you can try to recover the device from here. Okay, start before you do anything else. It's really important to load these things. Make sure you do a soft reboot. So there's reset the device there. Once it comes back, deselect everything else. Select the media loader first. Load that. Make sure it's successful. Then load this partition. Then the U-boot. That's the bare minimum for the device to boot, and then everything else. Okay. You need this file over here because it tells where to put things. Basically, a partition information. Okay, so that's going to be it. Hope you enjoyed it. There will be additional work to be made, as you're going to see in the video. Hope you enjoyed this one, and let's get to it. All right, so this is the setup. So I have actually a proper cable this time in here. It made a ton of difference. Also, this cable here, this cable's well, it's better than the last one. One of the other elements that was failing. I have this all the way plugged in. So I have my cheat sheet here. This is what we're going to do. This is a terminal here. I'm going to do a control A. We're going to change the baud rate to the original, which is this humongous number right here. Okay. Then I'm actually going to do. Okay, so let's see before we do that. See, okay, this is what I meant here. Now, if you're doing this from the GUI, I don't have it here because I'm not going to use it. But there's a file called conf.cfg, config.cfg, which is the one that you can load onto that GUI version of the thing to interact with us. Okay, so and this here has information about the device. And then you have this right here. Okay, it's basically a partitioning information, and you actually need this for the remaining things to fall into its right place. Otherwise, that's just not going to work. So let's see if I can get this. If I can get this thing to run. Okay. So first things first. Let's zero out this. Okay, I'm going to zero it out this way. Okay, so you didn't find the device. LD. It's not here. Cool. It's plugged off. So let's do. There's a button that you need to press first. Then you need to power on the device, and then eventually you only release that button once you see this. Okay, so we have the device here. Now what we're going to do is going to raise the thing. Yay. Okay, so it's going to be just go on this state right here. It's going to go, okay, say, yeah, reset. It failed to do so. Now, if we do, usually they say that if you do this this way, and then you do, the device is still there. And if you go this, there's actually a command that you can use to check on a few things. If you do this, you're going to see the device is just check failed, read chip failed. And so this is where the documentation and things in practice change slightly. Now, to be fair, they also said that these upgrading tool doesn't necessarily work really well on Mac. And that's precisely where I'm doing this, because, well, let's do that for another time. And it didn't work well with VMs, so let's leave that for the time being. Now, if we do a DB, this is going to load this alert onto memory. Okay, you're going to see this on the UART. So far, let's moving on. So this is basically a USB version of an image from the official vendor, okay, from the vendor itself. And it's one of the builds they have, one of the possibilities where they the images are meant to be loaded through USB. Okay, so we're going to load a few things. First, partition, then U-boot, then the boot itself. Okay, then the kernel. Okay, you could have jumped straight in onto the thing. I'm just showing how you can unbreak this thing because I couldn't find anything online. So resource. Okay, now we're going to load a DTBO. Okay, some of these are quite small. Okay, MISC is always a good sign. That's something that you can't quite name. This one's a bit big, so I'm going to stop the video for a second and come back on this once this is on. It's quite a bulky image. So let's go root.fs. Well, that one is done. Okay, let's see if this goes well this time. Okay, and use the data. This one is smaller, and this is where we're going to do this. So we're going to copy this over. To do this like that, and you're going to do the reset of the device, and ta-da! Okay, it's going. Okay, so we successfully reestablished the device. Okay, good news. Okay, now let's decide the PI here. PI, it's some of the defaults. IP link here. Just let's show something. Okay, now I have the original DTS, DTV, decompiled into a DTS source file, and actually inside there's a slight difference between the MAC address that is mentioned in the original one that I extracted and this one in here. What I'm going to do is I'm going to see if I can show you how you can go about extracting that in case you don't know. Okay. MAC address is quite important because if it's zeroed out, you can only connect to local network in some cases, depending on how you have things set up. It's quite important. You can't just make one up. Unless it's something that you're traveling with. I'm going to roll them. That's not going to be much of a problem. Now, I'm going to take this and put it in there. And we're going to just take a DD. Link is up. So it's a bit unstable. So I'm playing with a cable here. And I think with it. Okay, so we're using the UART, so we're safe. DD and in the running, DT device 3, you can, while the device is running, should be somewhere around here. Sys firmware FDT. We're going to save that onto the temporary folder. It's not as small as the OpenBSD one, but still, it's quite small. Okay. Okay, right. So now this utility allows you to basically decode the things. It's getting a bit too fast. So DTC-I, DTV, we're going to use capital O, DTS, basically converting one thing to the other, binary version to the source version per se, and a DTS like that. And if we do, here, it's mind copying commands over and over, it's a clumsy typer. You're going to see this inside, which is somewhat close to what we have here. Okay, that's one. Yes, 36, 18, yeah, pretty much. Okay, there's also that one, which I can't really tell where it's from. Let's leave it for now. We're going to leave that for now, and that's pretty much it. You should most definitely save things. Now, let's block. Okay. We have this here laid out, and in this is the original layout of the thing. And initially I thought that by clearing out the MMC, this part here was somewhat safe. I'm not really sure at this point, considering what I've seen so far. So some of these things, I'm going to see if I can get my hand around. So once you save that information, if you want to get started with the installation of the OpenBSD, what's going to happen is we're going to need to clear out the first gigabyte of the device like that. And we're going to do this this way. It's going to be a bit risky. Okay. Okay, and at this we can do reboot, and it's going to go a wire from here. Okay, it's pretty much done, I guess, unless something went off. We can turn off the device here. Yep. Just to keep things on here. And we're going to do the whole masking thing that I was talking about. Okay, it's in mask mode. Awesome, great. So here's what I am going to do. I'm going to DB and mini loader like that. Okay, just going to power on the device. Awesome. After this, there is there are a number of ways for us to clean up the MMC. One of the ways that I found that actually works is by first doing an SSD. Okay, ensure that we are on number 2. Okay. And now I'm going to essentially clear out the first gig like that. Okay. Okay, the reason why we're doing this is the upgrade tool is known to have a few mishaps here and there while cleaning the eMMC. And so we're trying to ensure that that is the case. Now, if you follow the full recovery steps from the beginning and have Linux, you can actually run, show you that command. You can actually run this instead. Okay, that case will basically get you around the hang. It is also true that there is an EF command like this, and you can run it just to be sure that the device is completely clear. Okay, it will basically fail the device. I'm going to reset it. Okay, and it's going to show again here in the LD as mask mode. Now, if it actually reset it, which I'm not sure if it did because I haven't seen anything in the UART cable, I should be able to do this and see the device responding. Okay, there is also another thing you can do. Have an idea whether or not things are going according to plan. Because if you can extract this, it means, roughly speaking, you might be on a good place. Okay. Next thing, what do we need bare minimum to start the installation? Well, first things first. We actually loaded this one here already. So, right. So this command works. That's already there. Next thing we need to load is basically the partitioning table. This is required for the tooling to know exactly where to put things. This is my current understanding of how this tool operates. I might be slightly off. Okay, next thing, we're going to do the U-boot. Okay, they have a slight, they're not all in the same place. They have specific offsets from where they stand. This is a deviation from the standard procedure here. After I do this, the device is going to be in a weird state. So I will have to essentially reset the device by hand. Okay? And set the MMC card in, which I'm trying to do right now. I think I did. Okay, now we'll do this. It's going to fail. It's okay. We're going to put the device again onto the state, shut it off, okay? Then put it on again. And now we can boot the installation media. And so it boots, okay? There are a few things though. If you look here, we don't have a MAC address. And so that's why we have that in there. Now, in the past, I managed to do something like this, okay? And actually make it work. Actually going to exit from here, okay? This is going to bring the install again. Okay, and now I'm going to set install. It's going to say yes. I'm going to set up the host name. And this is where I'm going to set a few things off. Okay, autoconf, yes. And now none. Okay, network config, that's done. Okay, now I believe that if I do a control Z now, do it like this, okay, I will have an IP address. That is, ooh, you don't have clear. Okay, and that is where things might be quite interesting because, okay, there's no, so we need to go onto dev, do make dev sd1, sd0. Okay, now I have a Python server running here somewhere. I'm going to see if I can download this thing. Okay, I'll show what this is going to do in a bit. Just to confirm that I'm on the right disk here. It's going to be, this one's going to be that. If I do 0, I'm going to have the news. So the 0 one in this case is the SD card. You want to be sure about that. And the other one is going to be my drive, the one that I cleared the partitions off. So I'm going to see if I can recover the layout like this. And then the port and disk labels like that. So in my hopes is that after I do this, okay, if I do that, I have this, okay, and this basically makes my life easier because this is the offset, right? I want for the EFI partition to stay there. And this is the sort of the hack that I came across to ensure that I have enough space to put U-boot like that. So after this, I can just, okay, so now I'm going to resume this thing. Okay, I'm going to hit enter. It's going to ask me for the root password. And I think the first time, yeah, then well, it's cool, it's fine. Okay, no. I'm going to say yes, but you should never do this like that. It's just that my username starts with a number, and I always try to get around that. So I'll have to change that later on. So SD1, all right. No. Okay, so I'm going to do E here just for edit, just to be sure that the installation is not going to load the default layout, okay, because I want to preserve my own. Okay, on this one, I'm going to set custom, okay, and if I do a print, you're going to see the layout that I saved before, right? And so here's what I'm going to do now. So I have here basically my hack cheat sheet here around that. So here's what I'm going to do: N and then A, and I'm going to set the mount point like that. So it's really lazy, so I'm going to set that like that. Then I'm going to say N B plus the that plus the fact that we have those offsets, right? So now we're done for that one, for this one. Now in here, this one here is where we're going to basically go back slightly to ensure that we can actually reach the network. Okay, so Control Z again. So thing. Okay, it's working. Awesome. Great. FG. We're going to hit enter. Is there any proxy? No, none. What's the host name? Yes, that's going to be it. Now, if everything, oh yeah, I love when a plan works. Oh yeah. Okay, minus game store. Okay, we'll remove that. Then we're going to do the same for anything that starts with an X. Boom. We're left with the bare essentials here. We could have also cleaned up the compiler there. I'm not really sure if I'm going to use it or not, so I'm going to leave it like that. Okay, so we're back with the this. Okay, location for the disk sets. We're done with that one. Okay, Portugal. It's going to be it. Okay, I was going to try to relink the things. Reboot. Now is where things will start to get interesting. We are going to reboot the device. Boom. Okay. It's going to sync up. And we're going to stop it right here. Okay. And there are a few things that we need to find out. We need to find where's the MMC. And like it's about to arrive. So there it is. Okay. And if we do that, if we know that, okay, what we're going to do now is set it like that. Boot. Hit enter. And for the first boot, you actually need the SD card to be in. All right, so device is already booted, but once again we have the clear MAC address, right? We need to solve that. So to get around that, what we're going to do is do this, set an IP address, MAC address, sorry, and then sh. Let's start. Yay. Okay, and after this, we should be able to do something really simple, which is transfer that rocket ship to Ray. So we have the file here. Okay, we have the boot file here thus far. Okay, so we're out. We are off to a good start. So we need to figure out what disk is the disk where the MC is. Okay. This is one of the disks. Okay. This is the other one, right? So our bet is that in this case, with the SD card in, we're talking about this drive being the one where we installed OpenBSD on. Okay, solid. Okay, now with knowing that our EFI is there on this offset, we should be good to go. So let's do that. Knowing that, I'm going to copy this thing here and cross my fingers. I'm going to plug the SD card off. Okay, so did that. We synced up. We already synced up, right? We'll call it sync just to be sure. And now let's reboot. Let's reboot this thing. And all right, so the device is booting on its own. It doesn't need the SD. In case you haven't catch that up, in the end, we end up overriding the U-boot onto its specific offset with one of our own. It is the same that we used on the first video, in case you're wondering. And that's pretty much it. There is that thing about having a all zeroed out MAC address that gets in the way of the installation procedure. And we still need to test the NVMEs, which is something that I'm going to do forward. The installation itself could be a bit more streamlined, I guess. Well, we can work on that. But it turned out to be actually quite successful. So if you want to see that operation in another video, just leave me leave a comment leave a comment. Maybe I'll do it if enough people request for it. If not, see you on the next one.